we can all agree that mathematics is something that you really have to dive into, to ask more questions in order to explore its true meaning. So in this video, I collected a few problems that I saw recently that I thought were interesting and that I wanted to share with you guys. So in these 4 problems, I will be sharing you my solution to all of these questions. And you can also pause the video anytime you'd like, solve the problem, and if you happen to get the same answer but using a different solution, then feel free to comment it in the comments down below. We're very excited to see what you guys have to say about these problems. So let's dive right in. This first problem is 25 to the x power plus 5 to the x power is equal to 20. And we're being asked, what is 5 to the x power? Pause the video and try to solve this on your own. Hint: you need to use one of the laws of exponents. So here's how I did this problem. First, I split 25 to the x power into 5 squared to the x power because I wanted to be able to combine like terms, and I knew that I could split 25 up into 5 squared. And then I turned 5 squared to the xth power into 5 to the xth power squared. So what I'm saying is 25 to the x power is equal to 5x squared, 5 to the x power squared. And I know this because one of the laws of exponents says that a number a to the mth power raised again to the nth power is equal to a to the nth power raised to the mth power. Well, this really, the actual thing is it's equal to a to the m times nth power. But if you split it up the other way, it still works. So this is how I swapped the 2 and the x right here into 5 to the x power squared. So now that I have 5 to the x power squared plus 5x is equal to 20, I replaced 5 to the x power with a, so it would be easier to solve. So then it would be a squared plus a is equal to 20. If you use the distributive property and you factor it out, the a, then you have a times a plus 1 is equal to 20, which means that a is equal to 4. So our answer would be 4 because a also represents 5 to the xth power. All right, so that was my solution for the first problem. You really have to be resourced when you're trying to solve problems like this because it doesn't tell you exactly what law you're going to need to use, what rule. You really have to really know all your basic math, and then once you really know those laws and those rules, you're going to be more easily able to remember and then apply that to problems like this. Now let's move on to the next problem. Okay, so again, if you want to solve this problem on your own first, you can pause the video. So here's my solution. The problem is x to the 9th power plus x to the 6th power is equal to 36. And I use the same law of exponents as the last problem. First, I split x to the 9th power up into x to the 3rd power cubed plus x cubed squared, and it's equal to 36. Now that I have x to the 3rd power on both of these, I replaced it with a. So here, I replaced x cubed as a. So that's how I got a cubed plus a squared is equal to 36. What made me want to split x to the 9th and x to the 6th was because I wanted to simplify the expression, and I knew that if I had the same term, I could replace it with the same variable. And then using the distributive property, I got a squared times the sum of a and 1 is equal to 36. Now you can think of it as two numbers being multiplied together. And the whole factor pairs of 36, there's only so much. So there's 1, 2, 3, 4 pairs. now all I did was list them all out and see which pair fitted it. So 1 and 36 would not work. And actually, there was a faster way of doing this. I underlined, as you can see, all of the perfect squares because I knew that one of these factors had to be a perfect square. So these two options were already eliminated because they did not contain perfect squares. I looked at this, the first option, and after testing each of them out, I found that 9 was what a squared equaled. A squared is equal to 9. So because of that, I know that a is equal to 3. Now you may say, well, can't a also be equal to negative 3? Well, it could, except in this particular problem, it was 9 times a plus 1. So a had to be 3, a positive 3, in order to make it work. Again, a is equal to x cubed, which means that x cubed is equal to 3, so x would be equal to the cube root of 3. So our final answer for this problem would be x is equal to the cubed root of 3. This is our final answer. Comment in the comments down below if you also got the same answer, but you did it a slightly different way. Sharing your solutions with other people and sharing your thinking is beneficial for both you and your peers. Anyways, so let's move on to the third problem. X to the x squared power is equal to 16. So how did I do this? I first split up x to the x power squared is equal to 16. And then after taking the square root of both sides, I got x to the x power is equal to 4. Now, although it could be a negative 4, but you can't have a negative number as the result of an exponent. So the result had to be positive 4, which meant that x is equal to 2 because 2 to the second power is equal to 4. So our final answer would be x is equal to 2. Now for the final problem. 500 to the 500th power over 250 to the 250th power is equal to what? So in here, you're being asked to simplify this expression. Again, pause the video if you would like to solve this on your own first. I saw that this was a fraction. One way to simplify fractions is to make it a more simpler fraction. So I wanted to see if there were any common factors on both the top and bottom that I could get rid of. And it turns out there was. You can think of this fraction as 500 times 500 times all the way times until you have 500 of these, 500 500s times together, over 250 times 250, and then you keep multiplying until you have 250 of these. So 250 250s. Now what you can see here is that there is actually in fact 250 groups of 500 over 250s. So what I did was I separated that out. So I have 500 divided by 250 to the 250th power times the remaining 500s being multiplied together, which was 500 to the 250th power. And then after simplifying this, I had 2 to the 250th power times 500 to the 250th power. And since both of these exponents are raised to the same power, it would be equal to 1000, or as here, 10 to the third power to the 250th power. So then after combining 3 times 250, I got 10 to the 750th power. And no, I did not bother to write out all 750 zeros behind the 1 because that would be exhausting and that would take way too much time. That's why here I just wrote 10 to the 750th power. These are the 4 problems that I wanted to share with you guys today. I hope you had fun looking at them and exploring and discussing them with me. If you have any other solutions or if you just have any comments for these problems, feel free to share it in the comments down below. Thank you so much for watching 3 Inquisitive Kids. Subscribe if you haven't subscribed yet, and we'll see you next time.